So we would actually be looking for very laggy. Anyway, we would have x squared equals a positive 2. Then I would take the square root of both sides to give me x equals positive or negative square root of 2. That's what x equals. The other one says complete the square to solve. So to complete the square, I actually want this one over here. I actually want this one over here because I want to complete the square on the left-hand side, and I want numbers on the other side. So to complete the square, we're going to have y squared minus 4y plus something equals 1 plus that same something. And that something is that b over 2 squared. Well, the b is negative 4. So it's going to be negative 4 over 2 squared. And over here, we'll also have negative 4 over 2 squared. Well, the left-hand side is the good side to do because we're completing the square. So we're just going to have y. And we're going to put whatever's in the parentheses, which is negative 4 over 2, which turns into a negative 2 squared there. And that's going to equal 1 plus, well, once again, negative 4 over 2 is negative 2. Negative 2 squared is 4. So it's really just 1 plus 4. In one step, I'm going to take the square root of both sides. So we're going to have y minus 2 equals plus or minus the square root of 5. We would add 2 to both sides, and we're going to end up with y equals 2 plus or minus the square root of 5, which was b. Know how to complete the square. All right, and this one will be one that's worth points, so if you got it wrong, you lost points because this was straight out of the homework. But based upon that, what questions do we have from the homework for people that may have got stuff wrong? Mary? 39. Did you say 39?
Yeah.
Okay. 39 was 3x squared plus 2x plus 1 equals 0. So we're going to have to complete the square to solve it, right? Because we didn't use the quadratic formula yet today. That would probably be more likely one that you'd use the quadratic formula for. But the first thing you'd have to do is divide everything by 3 because you have to have a 1. You have to have a 1 in your first term. So I'm going to divide everything by 3, which will give me x. Ooh, that's probably tiny, isn't it? Which will give me x squared plus 2 over 3x. And I'm going to kind of shortcut this by going plus something. And I'm going to have already subtracted that 1 on the other side, which would have been negative 1/3 plus something. Are you okay with all? I kind of did a whole bunch of steps at once.
Yeah, I just was being dumb and just thought once I divide by 3, like I did weird math where I thought it was like actually.
Oh, okay.
Square, but it wasn't.
Gotcha. Are you good from here, maybe?
Yeah.
Like you know what to do?
Keep going.
Sure. So then I'd have 2 over 3 divided by 2 squared. And then over on the other side, I'd also have 2 over 3 over 2 squared. Over here, we're completed the square, so that'd be x plus, well, 2 over 3 squared would be 2 over 6, which is actually 1 over 3 squared. Once again, if you want to see that, that'd be 2 over 3 times 1 over 2, which would turn into 1 over 3. Well, that's going to equal, oh, that's erasing. That would equal a negative 1/3. Well, once again, 2 over 3 over 2 is actually 1 over 3. And if I square that, it turns into 1 over 9. And I think that's about as far as I'm going to go. Because you should be able to combine those, subtract your 1/3 from both sides, and do it from there. Other questions? Yeah.
37.
37. Do you have a specific question?
Yeah, I got the first step.
Okay.
I got confused.
So this one we'd continue on and we get an answer.
Yeah.
For this one, I would divide everything by 2, which would give me x squared plus 5 over 2x plus something equals 12. Oh, it'd be 12 divided by 3, by 2 actually, so it becomes 6 plus something. Well, that something is going to be 5 over 2 divided by 2 squared. And this would be, you know what? Why would I do that? I picked the hardest way to do it. That way's solvable, but this one's actually factorable. So I'm going to go ahead and factor it. Factoring would probably be the easier in this case. So that would be a times c. A times c would be a negative 24. Our b is 5. So now I need two numbers that multiply together to give me 24, and they add up to 5. What two numbers are those? Yeah.
Oh, question.
Oh, yeah.
Like, how do you know, like, so you're starting with the completing the square first? Like, how would, like, I know which one?
You wouldn't.
Okay, so I would do completing the square and just do the long letter.
Yeah. Most of the times I'd probably put this one into a factoring one.
How do you realize what's factorable though?
I know the numbers.
Okay.
When you do enough of these problems, you recognize numbers. So what I'm looking in my head is I'm looking at the 2 times 12.
Yeah.
And then I'm looking at the 5, and I'm looking at, can I get two numbers that work for that? So if I was starting out this problem, before I would complete the square, me personally, I would look at these two numbers in my head. I'd look at negative 24 and 5, and I'd quickly look at the factors of negative 24, and I'd ask myself, are there any that add to 5? And if I can quickly think of two numbers, then I'm going to factor it. If I can't quickly think of it, then I'm going to go, okay, let's complete the square, plug it into the quadratic formula. Because you don't want to waste like 10 minutes looking for two numbers. But if you can immediately see something that stands out to you, might work,
Okay.
then I would go ahead and do that. Can anyone think of two numbers that multiply together to give you 24 and add together to give you 5? Yeah.
8, negative 3.
8 and negative 3. Nope, not there. Put it there. 8 and negative 3. 8 plus negative 3 equals 5. So do you kind of see how it didn't take long to think of two numbers that multiply together to 24. And if it doesn't work, then you go, scratch that. Let's do completing the square. Or because factoring is, I think, the easiest.
Yeah.
Because a lot of it you can just do in your head. So now let's go ahead and factor this. So that's going to change my positive 5 to an 8x and a negative 3x. We'll drop down that 2x squared. We'll drop down that negative 12. We're going to treat this as two binomials because that is our point of doing this. I got that guy. I got this guy just hanging out here. Biggest thing that come out of 2x squared is actually 2x. 2x squared divided by 2x is just x. 8x divided by 2x is equal to 4. I'm going to pull a negative 3 out of those other two. That'll give me x plus 4. Wow, wow, wow. These both are the same. I did everything correct. I know, it's stunning. And then we have 2x minus 3 times x plus 4 equals 0. So it'd be negative 4 and a positive 3 over 2. But Ross, does that kind of answer your question?
Yeah.
If there's small numbers like this, I mean, if it was really big numbers like 3 and 64 or something, like if I had 3x squared plus 16x plus 64, I'm probably not going to think of two numbers really quickly.
Yeah.
But it is a good thing just to go off to the side and write down, okay, negative 24, 5. Can I think of two quick numbers? Yes, I can, negative 3 or 8. Or no, I can't, then I'll complete the square or plug it into the quadratic formula.
All right.
Okay. Other questions from the homework, though? All right, then let's talk about the quadratic formula. Yay! The quadratic formula, the end-all, be-all of solutions that everyone's going to use all the time, even though it's not the most appropriate in every case. Our quadratic formula is every solution for x in the equation ax squared plus bx plus c equals 0. It must be 0. You must have a 0 on the other side. So look at b. Is b set up right off the bat? No. So you're going to have to do some work on that one. All right, our equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You have to know it. You have to have it memorized. Now, all that's pretty good and fancy, but first you have to know what your a, b, and c are. So let's look at our first example. Our first example is ax squared plus 8x plus 3 equals negative 3. We got a problem. Houston, we have a problem. That negative 3 needs to be a 0, so I'm going to add 3 to both sides. And that's going to give me x squared plus 8x plus 6 equals 0. Now, real quick, whatever number's in front of your x squared is going to be your a value. Whatever's in front of your x is going to be your b value. Whatever is left over, your constant, is your c. So your c is your constant. And now this really is just a plug and chug type equation. You plug the numbers in and you keep working away until you solve for x. So in this case, we're going to have x equals negative b. Our b right now is a positive 8, so that's going to be a negative 8, plus or minus the square root of a squared, bless you, and minus 4a. My a is actually a 1, because there is a 1 in front of that x squared. And our c value is 6. And that's all over 2a, which would be 2 times 1. Now we just have to whittle our way down. A whittle way. Usually you're going to simplify everything that's underneath the square root first. So that's 8 squared, which is 64. 4 times 6 is 24, so that's going to be square root of 40 underneath the radical bar. Most of the time, you're just going to plug that in your calculator. You'll just type in 8 squared minus 4 times 1 times 6 and see what that comes out to. It should come out to 40, and then it's all over 2. Well, that isn't done. That isn't simplified. We can simplify that square root of 40. Square root of 40 can be rewritten as what? Ross?
2 square root of 10.
2 square root of 10. Perfect. 2 square root of 10 divided by 2. Believe it or not, we can go further. There are actually 2 fractions there. So if you left it like this, I'm okay with that. I'm not okay with that in this one. I lied. Because you're going to see when I split them up into fractions, I can actually simplify stuff. If this would have been over 3, we'd probably just leave it like that. And I'll show you what I mean by it's going to simplify down further, because I'm going to go down to the next row and split it up into its 2 fractions. Its 2 fractions are negative 8 over 2 plus or minus 2 square root of 10 over 2. You can push this together so you can split it apart here. Now with it split apart, you can see that you can simplify this even further down to a negative 4 plus or minus square root of 10. So when you can simplify this, if this bottom term goes into both of these, what I'm looking for is, does it go evenly into both of these? Then you need to go this extra step. If this was a 3, 3 doesn't go into 2, 3 doesn't go into 8, so you would be done right here. So you are looking for, does this go evenly into both of those? If it does, you do need to simplify. I want you all to do right now, I want you to go through B if you haven't already. So I want you to do B right now if you haven't already.
The formula.
Graphs of quadratics. Remember, quadratic is a U parabola shaped graph. Well, this says how are you going to determine what your real solutions are based upon a quadratic graph? Well, when you are looking for solving, so if we look at this thing up here, it says I'm looking for ax squared plus bx plus c equals 0. So realistically, I'm looking for where does y equals 0 on the graph. And y equals 0 on the graph right here. That's where y equals 0. So where our graph intersects that line is our solution to that problem. So in this case, we have x squared minus 9. So x squared minus 9 equals 0. It's going to happen at 2 places. It's going to happen here, and it's going to happen here. Well, right here is where x equals 3. Right here is where x equals negative 3. So our solution has 2 solutions, 2 real solutions, and they are in fact x equals positive and negative 3. So not only do I know it has 2 solutions, I actually know what they are. Well, the next case, if we look at where, yeah, sorry.
Where did you get x squared minus 9? Is it?
Oh, it's right up here. It's written up here. Sorry. Yeah, it's on the, I took a screenshot of my thing. So this is the thing I plugged in. Like here I plugged in 2x minus 1 squared.
Oh, okay.
Yep, sorry. Lo siento. That's how I know the equation. I'm just not, I didn't just look at it and know it.
Yeah, okay. So
I would have known that one actually, but yeah.
are we gonna like have the equation there? Like,
Yes, you're going to have the equation.
okay. I was like, how'd you get negative 9 there?
Yeah. So our next one would be 2x minus 1 squared, right? So our next one would be 2x minus 1 squared because it says it at the top left corner. And I'm looking for where it equals 0. Well, once again, I'm looking for where y equals 0, so I'm looking at this line. Well, in this case, there's only one real solution. It has a multiplicity of 1, but it only has one real solution. One real solution. And that's where x equals 1. I'm sorry, not 1, but 1/2. I glanced at the graph too quick. Because that is halfway between them. I drew that stupid red line over it, causes everything up. All right, our last one is, where is x minus 3 squared plus 8 equal to 0? So once again, x minus 3 squared plus 8 equal to 0. So you're asking yourself, when does it cross this red line? It does not. There are no real solutions. There's imaginary solutions, but there are no real solutions. That's when you'd have like that I square root of 4 or something. Well, that would be 2i, but yeah.
How do you imaginarily graph something?
We're not going to get into that. But there are two techniques to that. We did this already. We turned one of the axes into an imaginary and one into the real axis. We did that in first mark period. And then the other way is to actually flip this graph onto an imaginary plane.
Cool.
It's pretty cool. Realistically, all you have to do is flip it all the way around, and you can actually see your imaginaries. But we're not going to get into that. We're neither here nor there. But the big point of that was there are 3 possible things that happen with a quadratic formula. You either have 2 solutions, 1 solution, or no real solutions. There's no alternatives to that. The cool thing is the discriminant will tell you how many solutions it has. You don't have to actually solve the whole thing. We could just use the discriminant to solve for how many equations or how many solutions it will have. So one of the most interesting parts of the quadratic equation is it provides us with an easy way to determine how many solutions exist. The expression b squared minus 4ac is known as the discriminant because it determines the number of solutions that you are going to have. So that is what's underneath the square root symbol. That is your b squared minus 4ac. That's all you need, and you can tell me how many solutions something's going to have. So we have 3 different cases. Either our discriminant's positive, our discriminant equals 0, or our discriminant is less than 0. Let's write each possibility underneath it. Well, if we look at this one, we're going to kind of half fill in the quadratic formula. Our quadratic formula is negative b plus or minus the square root of the discriminant. Well, in this case, it's a positive number. And it'd be all over 2a. Can you take the square root of a positive number? Yeah. So that means you're going to have 2 solutions. This is like square root of 4. It'd be like negative b plus or minus 2 over 2a. You have 2 possible solutions if that is 0. So we have 2 solutions. I should put 2 real solutions. So if your discriminant is positive, you have 2 real solutions. Our next one is if it equals 0. Well, in this case, you'd have negative b plus or minus the square root of 0, which is just adding or subtracting 0. Does adding or subtracting 0 change your number? No. Is 4 plus 0 any different than 4 minus 0? No. So how many solutions would this one have? It would have 1 solution because you no longer have a plus or minus. You just have negative b over 2a. So in fact, this one would just equal negative b over 2a. You have 1 real solution. All right, our last one, we're going to have a negative under a square root. right off the bat, what happens when you have a negative under a square root?
Imaginary.
You go into imaginary land. It's a fun thing. So we have plus or minus the square root of negative. That would be imaginary. So we just pretend it exists, I guess. Over 2a, so that is going to be no real solutions. But it will have two imaginary solutions. So that's something to keep track of. That would have two imaginary solutions. All right, those next three ones, I don't know why I did three of them. Oh, because I did one for each one. That's why. Blech. All right, we're just going to run through all three of these quick examples. All right, so it says state the value of the discriminant and the number of real solutions. So we just need to do our discriminant, which would be b squared. So in this case, it'd be 8 squared minus 4. Our a is 1. Our c is 6. So that's going to equal 8 times 8 is 64 minus, looks like 24 is going to equal 40. 40 is definitely positive. 40 is bigger than 0, so you're going to have 2 reals.
Real?
Reals. It get reals up in here. Our next one is 5x squared minus 4x plus 1 equals 0. It's set equal to 0. So we're going to go b squared, which would be negative 4 squared, plus 2ac, 4ac. Why am I saying 2? But times 5 times 1. Did I do plus? Yeah, I did. I quit. Okay, so we have negative 4 squared. 4 squared is going to be 16, and that's minus 20. So that's going to be a negative 4. How many?
4 negative.
What was that?
She said.
So we're going to have no real solutions. Guess what the last one's going to have? 1, 0. Okay. First, we have to make sure it's equal to 0. So we need to have 4x squared plus 12x. And it'd be plus 9 equals 0. Then we're going to have b squared, which is 12 squared minus 4 times 9er. And that would equal 144 minus 4 times 9. Yeah, that'd be 144 as well. So that would equal 0. We have 1 real solution. All right, questions on that?